In this next video, we are going to look at setting up the analysis of an off-grid home power system. So what is it that we want to provide power to? Well, it's an off-grid home, and I'm going to presume this is a made-up example, but it's an off-grid home in Wyoming, located near Cody. The AC electricity requirement, we're going to assume, is 6 kilowatt hours per day, with a peak electricity requirement of 10 kilowatts. And the system must be able to provide power a minimum of 8 hours per day. It'd probably be nice if it could provide it for 24 hours a day, but as we'll see, this may be challenging for certain technologies. The diesel fuel price in this location is US $4.80 per gallon delivered, and we're going to assume that the homeowner is handy and can do basic maintenance. In order to supply this, we want to compare two systems and determine whether the proposed case system makes sense compared to the base case system. So the two systems we want to compare are the proposed case of a photovoltaic plus battery system to the base case of a diesel-powered generator. And when I say makes sense, I essentially mean I want to answer the following questions. First, in order to answer the other questions, I'm going to need to determine the size of battery and photovoltaic array necessary to meet the stated electricity requirement. Once I've done that, I need to find out their capital, operating, and maintenance costs. And I need to compare those with those same capital, operating, and maintenance costs for the diesel-fired generator. So that way I've got the incremental costs of the proposed case over the base case. Then when I go to the financial analysis, I'm going to want to look at the profitability and quickness of return. That is, based on the incremental costs of the proposed case, is it profitable to use the photovoltaic plus battery system, and do the savings in fuel costs that it generates pay for the investment that the homeowner is required to make in a reasonable amount of time. And finally, because some people might be interested in knowing the environmental attributes of the project, we'll want to calculate the impact on GHG emissions. All right, let's switch to the software then. We see here the File tab for RETScreen Expert. There are other tabs across the top here. Not all of these tabs are associated with the feasibility analysis. Indeed, if I go here to Getting Started Options and I pick Feasibility to start a new blank project, you'll see that a number of these tabs disappear. And we're down to this set, which is essential for the feasibility analysis. There are other ways to start our project as well, given here on the File home screen. The Virtual Energy Analyzer, which I referenced earlier, allows us to start with some default values based on a few questions about our particular analysis. We can also access case studies and templates here, or example projects here, which could serve as starting points for analyses. We have access to other file functions on this screen as well, opening and closing, accessing our files, saving. At the far right here, we have a variety of functionalities. The one that I want to point out is a link to RETScreen's YouTube e-learning channel. So there's some useful additional information there. The tabs across the top here for the feasibility study, I'm just going to introduce them briefly now. So in addition to the File tab we're looking at presently, there's the Location tab, where you can specify the project location and the climate data location, and then view the climate data location, view the climate data for that location in these tables. The Facility page is where we configure RETScreen for the type of facility, and we can enter information that identifies us so that if, for example, we incorporate that into a report, that potential clients know who did this work. The energy page is where we specify the technical parameters that describe our system that allow its energy performance to be calculated by RETScreen. On the cost page, this summarizes all the initial and annual costs, as well as if we select more detailed analyses, that is level 2 or level 3 here, we can also specify periodic costs, which are costs that occur on a recurring basis longer than 1 year. So every 2 years, every 3 years, every 4 years, etc. On the emissions page, we find our GHG emissions analysis. The finance page brings together key results from the energy, cost, and emissions page in a financial analysis which allows us to investigate the profitability, for instance, the internal rate of return on equity, as well as the quickness of return through such things as simple payback or equity payback. There's a risk tab, which we're not going to talk a lot about, but it allows us to do a sensitivity analysis and a risk analysis. There's a report tab where we can generate some standard reports and make some customizations to them. And then a custom tab where we can select elements of our study and bring them into a dashboard, which then reflects the project. Returning to the File tab here, the one thing that I think I would like to show to you is the settings here. So in settings, we can control a number of different aspects of the analysis, such things as units, currency, language. And language is also accessible here. You can see that RETScreen can be used in a large number of languages. Most of the parameters you select, and then they are applied to all future analyses until you update that parameter. But here on the settings page, there's also this column for just the current analysis. So just for this analysis, one of the things I'd like to change is the currency. Currently, it's the $sign. However, the $sign is used both for the Canadian dollar and the American dollar. And this software is Canadian, so that can lead to some ambiguity. So what I'm going to do is to make this explicit, I'm going to select the United States of America. Then our currency is clearly the US dollar, and I'm going to specify the exchange rate. At the time I'm recording this, it's about 1.35 or $1.35 Canadian per US dollar. So I'm going to enter that there. Clicking on the Location tab, our first job, and really the only thing we have to do here, is to select our climate data location. So we've been told that this is in Cody, Wyoming. So I'll enter that there, and I'm given a list of choices. In this case, the list only consists of one item, of names that satisfy the text I've entered. So here's Cody. I can zoom out to see exactly where this is. You see that we're not too far from the mountains. This is a hypothetical example, so I can place this anywhere. Normally you would try and place this thumbtack, which has the little building on it, at the location where your building is. The other thumbtack, this one here, indicates where climate data is being taken from. So the nearest site for climate data is Cody itself. It has a red dot. Red dot indicates that there is at least some data that has been taken from a ground station. That is a ground measurement there. Where you have only blue dots like here or here, that is a location where all the data has been generated from satellite measurements. And we can see the distance between the two thumbtacks. It's 34 kilometers, which is reasonable for a solar energy project. I can look at this in satellite view as well, which can be helpful sometimes to get a sense of the terrain where you're working. When I'm satisfied with my choice here, I can click on this button, Paste Data here, and this climate data gets updated, as you can see there, with the climate data for Cody. I'm going to talk more about this climate data in some upcoming videos here, but I just want to point out a few things. First, on settings, I neglected to pick US customary units as my unit choice, or imperial as it's called there. So most of these units or all of these units are in metric currently, but I still have the option to select individual units for each of these parameters. So in this analysis being done for Wyoming, you might want to look at some of these in terms of U.S. customary units. At the bottom here, there's a graph of two different climate parameters. So the bars are showing daily solar radiation on the horizontal for each month. So we can see, yes, in summertime they get a lot more radiation on average on a horizontal surface than in wintertime. And in the other parameter is air temperature. That's with the green line here. So yes, in summer it's warmer than winter. So that's just showing two different parameters that we can select. These happen to be the two critical ones for a solar project, right? First, the solar radiation, although this one is showing it on the horizontal, and obviously if our panels aren't horizontal, we're going to have to transform that somehow. RedScreen will help us do that in the energy page. Temperature also affects the efficiency of the modules. Next, on the facility page, we verify that we have feasibility chosen here. If you're not finding the tabs that you need for your feasibility analysis, it's probably because you have performance or benchmark selected here. By default here, we have power plant selected. This is actually going to be an off-grid project, so I'm going to select that, and that configures elements of the analysis so that they're appropriate for an off-grid system. This is indeed an off-grid photovoltaic system, so I'll pick that. I could give it a description. I could say it's a domestic system. I could also put in my name here, for example. I could say, or not my name, but rather this is prepared for Heat Spring, and it's prepared by myself. And I could even click on this over here and enter some details about myself so someone looking at this could find me. And then I could say the facility name, so I could say it's XYZ House. Put in the address here if I wished as well. At the bottom, there's a benchmark section. I'm not going to talk about benchmarks that much, so actually I'm going to make it go away because it doesn't have any direct impact on my feasibility study, so I don't want any confusion between of the relevance of the benchmark to the feasibility study. It's completely independent, so I'm making it go away. I could change this image by selecting this image here and putting in some other image, but for now I'm okay with what we've got here. To recap, we've now set up RedScreen ready to do the type of analysis that we want. We've got US dollar as the unit, so we did that on the file page. We've got our climate data location specified, so we have climate data for this. Now, in the next steps, we will just need to go to the energy page, the energy tab there, and start specifying the characteristics of our system. And we'll do that by looking first at the load, the electrical load, and the base case power system. So that is the diesel-powered generator that we're comparing our photovoltaic battery system to. So that's what we'll do next.